we are going to discuss a very important problem. The problem here is to find the value of a triple integral. Okay, a value of triple integral is what we want to evaluate. So the triple integral is given by triple integral of root of a square, b square, then c square minus b square, c square, then x square minus c square, a square, y square minus a square, b square, then z square then we are having dx, dy and dz. Okay, dx, dy and dz, and we know here it is to evaluate volume. So the where is V is the region defined by x greater than or equal to 0, y greater than or equal to 0, then y greater than or equal to 0 and z greater than or equal to 0, z greater than or equal to 0, and also we are having x square by a square plus y square by b square. I shall repeat the question once again for you after adding this equation, plus z square by c square, z square by c square equal to not equal to, it is less than or equal to 1. Okay, it is less than or equal to 1. Okay, now we want to evaluate this. How to evaluate this? Okay, that is a question. First of all, we have to do something which will make the integral very simple. So integral here is triple integral over v. Okay, now I have started solution. Okay, so as I repeat the question, evaluate triple integral over the volume v for root of a square, b square, c square minus b square, c square, x square minus c square, a square, y square minus a square, b square, z square, dx, dy, dz, where v is the region defined by x greater than or equal to 0, y greater than or equal to 0 and z greater than or equal to 0, and x square by a square plus y square by b square plus z square by c square is less than or equal to 1. So now to make this as simple, I am taking root of this a square, b square, c square outside. Okay, b square and c square outside. So I get 1 minus x square by a square x square divided by a square, because that is missing in this term, minus y square divided by b square minus z square divided by c square, z square divided by c square. Okay, into dx dy and dz. Okay, now see what are the terms you are having common. This x square by a square is here, and x square by a square is here, and y square by b square is here, and y square by b square is here. Z square by c square is here, and also z square by c square is here. If I take minus commonly outside, I can put x square by a square plus y square by b square plus z square by c square, which is presented here. So the value is less than or equal to 1. Okay, that is first thing. After that, we are having the limits x greater than or equal to 0, y greater than or equal to 0, z greater than or equal to 0, which means x, y and z are positive. X comma y comma z are 0 or positive. Okay, 0 or positive. They are not negative. Okay, they never be negative. Okay, that is what given. Okay, after that we want to find the limit. So before finding the limit, we know that the lower limits are 0. The lower limits are 0. What will be upper limit? So for finding upper limit, I am substituting this x square by a square to be capital X. X square by a square to be capital X, and y square by b square to be b square to be capital Y, and z square by c square to be capital Z. Not to differentiate, I am writing a dash in between. Okay, for Z. Okay, now if I differentiate these three things directly, I will get 2x divided by a dx equal to d capital X. But what is the thing? The thing here is I don't want this x to appear again in these terms. Okay, I don't want this small x to appear in these terms. Okay, so in order to neglect that small x, okay, not neglect that small x, I am doing power reduction. That is, I am going to take square root on both sides before differentiation. So after taking square root, it will be like x by a equal to root x. Okay, it will be x divided by a equal to root of capital X, and y by b equal to root of capital Y, and z by c equal to root of capital Z. Okay, root of capital Z. Now after differentiating, so before differentiating I shall write the powers at x equal to a root x, a root x, y equal to b root y, and z equal to c root z. Okay, now on differentiation we get dx equal to, if I differentiate root x, I get minus a divided by 2 root x, because 1 by 2 x power minus 1 by 2 will be the derivative of x power 1 by 2 to root x. Okay, and dy equal to minus b divided by 2 root y. Okay, and dz equal to minus c divided by 2 root z. Okay, since we already know that x small x is greater than or equal to 0 is positive, small y greater than or equal to 0 is positive, small z greater than or equal to 0 which is positive, which means xyz lies only in the first quadrant. Okay, if I take x and y means it lies in first quadrant, or if I take xyz means I think it will be lies in the first octant. Okay, so this dx will not be negative, so here it will be positive, I am writing this in the next step also. We get dx equal to a, okay, a divided by 2 root of capital X. This is a, comma, d small y equal to b divided by 2 root of capital Y, and z small z dz equal to c divided by 2 root of z. Okay, these things are important. Okay, then we want to substitute all these things here. Okay, so before substituting that we shall write, we shall find the limits also. Okay, so what will be limit? We have to find limits. Since x greater than or equal to 0, capital X also greater than or equal to 0, capital Y greater than or equal to 0, and capital Z greater than or equal to 0. Okay, capital Z greater than or equal to 0. Okay, now we are having x square by a square plus y square by b square plus h square by c square is less than or equal to 1. This x square by a square is capital X, this is capital 1, this is capital Z. So we are having x plus y plus z is less than or equal to 1. Okay, so x plus y plus z less than or equal to 1 means I am writing it as equal to. Initially for my easiness I am taking it as equal to. So z equal to 1 minus x minus y. So if it is less than or equal to means, z will be less than or equal to 1 minus x minus y. So while writing the limit of z, I am having this. While writing limit of y, I will not have z. See, while writing the limit of z, I am not having z on right hand side. Okay, by writing limit of y, I will not have both y and z on the right side. That is, I am having y less than or equal to 1 minus capital X. Okay, and x less than or equal to 1, x than or equal to 1. So x greater than or equal to 0 to 1, y greater than or equal to 0 to less than or equal to 1 minus x, z greater than or equal to 0 to 1 minus x minus y. So with this knowledge and with these preliminary things, we are finding the volume of the given triple integral. So we are having triple integral of since this a square, b square, c square is inside root, if I take them as outside root means I will get a b c. Okay, a b c of root of c1 minus x minus y minus z. Very good. And after that we will have what will be y of dx equal to a by 2 root x, root of capital X dx. Okay, then b divided by 2 root y of dy, and after that c divided by 2 root z of dz. Okay, will be given. Now I am having a b c here also and here also. Both these things will be taken as a b c the whole square, that is a square, b square and c square. Now in the here we have to write limit. The limit of x is we are having the limit of x is 0 to 1. Okay, the limit of x is, we shall start from here. So see, listen, I want to rewrite this before writing the limit. I would like to rewrite this. Yes, I would like to rewrite this as following things. The first thing is integral. See, so I shall write here itself triple integral a b c of root of 1 minus x minus y, 1 minus x minus y, 1 minus x minus y sorry, one minus x minus y, okay, root here I'm having 8, 1 divided by 8 root of, okay, root x 1 by 8 into root x root y. You can simply put root of x by z, but there is a reason because I am writing like this, okay, you know it later, into I am writing first dz, then dy and dx. Okay, so what will be limit of z? The limit of z is 0 to 1 minus x minus y. Okay, limit of y will be 0 to 1 minus x. Limit of x is 0 to 1. Okay, now we have got our required structure. Okay, now we shall find this value or value to this integral function. So we are having a square, sorry, abc the whole square. I shall write it as abc the whole square, abc whole square divided by 8 into integral 0 to 1 integral 0 to integral 0 to 1 minus x integral 0 to 1 minus x minus y. Okay, now see, while we are integrating with respect to z, these x and y are constants. Okay, I am considering there is a mistake here. I am considering this 1 minus x minus y minus z. I am considering this 1 minus x minus y minus z as the function of z. Okay, as the function of z. So I am having root of 1 minus x minus y minus z into z power or okay, z power minus 1 by 2, z power minus 1 by 2, z power minus 1 by 2 dz dy dx, dz dy, and see, listen, what z is this? This is capital Z. Okay, dz dy and dx Okay, now I am having some constants here, that is root x and root y. So the constant which is a function of y can be written here, that is y power minus 1 by 2 dy. Okay, dy, and constant which is the variable of x can be written in x, that is x power minus 1 by 2 into dx Okay, now again we have to do this process repeatedly. The constant which will be the function of some other variables has to be bring to a corresponding integral. Now since this is too complicated to solve, I am taking this one I am taking this term as some other constant. Okay, so you can know that in few minutes. So ABC the whole square, ABC the whole square by 8 integral 0 to 1 x power minus 1 divided by into dx integral 0 to 1 minus, see here is also it is capital X. Okay, it is capital X, capital Y. Okay, you have to be very conscious with that. Okay, 1 minus X, 1 minus Y and 1 minus Z. Okay, it is 1 minus 0 into 0 to 1 minus X into Y power minus 1 by 2 y power minus 1 by 2 dy. Okay, and after that here we are having the term 1 minus x minus y minus z. Okay, whole power 1 by 2 z power minus 1 by 2 dz dy and dx. That is here 0 to 1 minus x minus y, 0 to 1 minus x minus y. Okay, now this is equal to I don't think this to be solved very easily, so there will be some complications. So in order to avoid that complication, okay, not avoid that complication, okay, not avoid that complication, I am writing here not avoid that complication. I am going to write it as integral 0 to 1 minus x minus y as capital A. 1 minus x minus y as capital A. So this 1 minus x minus y is capital A. Okay, capital A minus z. Okay, minus z whole power 1 by 2 z power minus 1 by 2 dz. Okay, dz. See, listen here, the terms will not come, dy dx here. Okay, actually we shall keep them here and not here. Okay, I am removing from here. Okay, because usually we used to write x dx y dy, that's why I have written here, but here these things will not come. Okay, now we are having dz dy and dx. Okay, now I'm going to take this a outside. How to take this a outside? So here I shall take a b c the whole square divided by 8 into integral 0 to 1 x power minus 1 by 2, this is a constant. Okay, integral 0 to 1 minus x y power minus 1 by 2. Now I am separating everything. Okay, you can separate in previous steps itself, but I am separating now itself. Dx, it is our wish, we can separate it at any time. Now I am separating because I am going to take this a separately outside, so it will make some confusion. So I am having a power 1 by 2, which is a constant, integral 0 to a 1 minus z divided by a, okay, whole power 1 by 2 z power 1 by 2 dz, okay, into dz. Now see, I want to make it as a single factor. In order to get integral 0 to 1 x power m minus 1 into 1 minus x power n minus 1 into dx, so that I can get beta of m comma n. So for that I am taking z divided by a equal to u. Okay, z by a equal to u. Okay, then z equal to a into u. The z here is capital Z. Okay, always keep in mind the z here is capital Z. Okay, so z equal to au, dz equal to a du, dz equal to a into du. There is no problem if you take capital U or small u. Okay, so the limit is changing from z to u. So we want to find the limit of u from the limit of z, from the limit of z. So the lower limit of z is 0, the upper limit of z is a. Okay, so the upper limit of u will be, lower limit of z will be 0 by a equal to 0, upper limit is a by a equal to 1, a by a equal to 1. Okay, a by a equal to 1. So now this term can be written as integral 0 to 1 minus 1 minus u. Okay, so first of all I shall write this term first. U, what is u? U equal z equal to au. So okay, we shall write here itself. And the next step we can rewrite this. So we shall have 1 minus u whole power 1 minus u whole power 1 by 2 and here we are having au power minus 1 by 2. A power minus 1 by 2. dz means a du. Okay, a into du. Okay, a into du. Okay, now so now we are having this. Okay, so for this we shall write okay, see a power 1 by 2, here is also an a power minus 1 by 2, so it will be minus 1 by 2 and there is one a, so that is plus 1 integral 0 to 1. I am writing this u first. Okay, u power minus 1 by 2 into 1 minus u power, okay, 1 minus u power 1 by 2, u power 1 by 2 into du. Okay, now I am taking back, okay, du. I am taking back all these terms because there I feel some I think there will arise some disturbance. That's why I have written everything here. Now I have taken again dy dx here. Okay, now what will be the value of this? What will be the value of this? What will be the value of this? The value of this will be beta of see x power m minus 1 minus x power n minus 1 dx. So m minus 1 equal to minus 1 by 2 and n minus 1 equal to n minus 1 equal to 1 divided by 2. m equal 1 minus 1 by 2 is 1 by 2. n equal to 3 by 2. So beta of m comma n will be beta of 1 by 2 comma 3 by 2. Beta of 1 by 2 comma 3 by 2. Okay. So we are having x power minus 1 by 2 into y power minus 1 by 2 into a power 1, that is only a we will have, a into, I am writing here very closer, I'm writing a very closer. So a into beta of, okay, a into beta of m comma n, that is 1 by 2 comma 3 by 2, 1 by 2 comma 3 by 2 into dy dx, okay. Now I think since there are only minimum number of terms, I think I don't want to take this x and y back, because the terms are very minimum. I can manage with writing this without any error by simply looking into this. Since the above term is very high and the above term is very long, so I want to differentiate it with what are the variables, what are the constants. So I retake x and y back to the original position at integral side. Okay, now I have taken back again to the last position, and I can easily solve it now since it is having only minimum number of terms. Okay, now a b c the whole square, abc the whole square by 8 integral 0 to 1 x power minus 1 by 2 integral 0 to 1 minus x. What is the value of a? Y power minus 1 by 2 into the value of a is 1 minus x minus y. The value of a is, see, 1 minus x minus y. Okay, I have expanded here a equal to 1 minus x minus y. Okay, a equal to 1 minus x minus y. Okay, a equal to 1 minus x minus y. Capital A equal to 1 minus x minus y. Okay, whole power minus 1 by 2, sorry, which is just 1 minus x minus y. Okay, and after that we will have dy and dx, and after that there is a constant beta of 1 by 2 comma 3 by 2. Okay, 3 by 2. Now I want to put this 1 minus x as again another constant, that is I am taking this as b, capital B equal to 1 minus x. So I get that is equal to a b c the whole square divided by 8 into integral 0 to 1 x power minus 1 by 2 integral 0 to what is 1 minus x, b into y power minus 1 by 2, 1 minus x is b minus y, b minus y, okay, b minus y whole power whole power 1 that is into dy dx of, that is a constant, beta of 1 by 2 comma 3 by 2. Okay, now I am taking this b commonly outside, that is equal to a b c the whole square by 8. What is b actually? B is 1 minus x, no? So I should not take this outside the integral of involving x as the variable. So just I am keeping x power minus 1 by 2. Okay, that if I take that b outside, I get integral 0 to b y power minus 1 by 2, then 1 minus capital Y divided by b whole power 1 into dy dx. So now I substitute y by b equal to v. Okay, y by b equal to v, then y equal to v. Okay, now dy equal to d b into dv, b into dv, the limits are y, for y we are having 0 to b, for v we are having 0 to 1, because v equal to y by b, so b by b will be 1. Okay, very good. Now we have found the limits of our second integral also. Okay, so now we are having, that is equal to here is one constant beta of 1 by 2 comma 3 by 2 comma 3 by 2 by 2. So here ABC whole square ABC the whole square divided by 8 integral 0 to 1 x power minus 1 by 2, we are having b here. Okay, so b into integral 0 to 1 y power minus 1 by 2. Okay, y power minus 1 by 2 means it will be b into v power b. Okay, b into v power minus 1 by 2, okay, y equal b into 1 minus y by b, 1 minus v power 1 minus v power 1 into dy. Value of dy is b dv into beta of 1 by 2 comma 3 by 2 by 2 comma 3 by 2. Now I have to take this b outside, that is b square into b. Okay, that is we have to check whether it is correct or not. So previously we are having e power to 1 minus y by b, we are checking. Okay, see, so here it is y power minus 1 by 2, that is b v power minus 1 by 2, b v power 1 by 2. So dy equal to b into dv, so b into dv. So if I take this, here we are having b square minus 1 by 2, so I am having a b c divided by 8, this is square abc whole square integral 0 to 1 x power minus 1 x power minus 1 by 2 x power minus 1 by 2 b square minus 1 by 2, that is b power 3 by 2. Okay, b power 1, then this is b power 1, 1 plus 1 is 2, 2 minus 1 by 2 is 2 minus 1 by 2 is 3 by 2 into integral 0 to 1 v power minus 1 by 2 1 minus v into dv into beta of 1 by 2 comma 3 by 2. Okay, 3 by 2. Now we are having a b c the whole square, okay, whole square divided by 8 into integral 0 to 1 x power minus 1 by 2 minus 1 by 2. See, here we are having, after dv we are having dx, of dv we are having dx. We should not miss any terms, even if we are solving a very big sum, we should not miss any term. Okay, here it is dx, x power minus 1 by 2 b power 3 by 2 which is b power 3 by 2 into integral 0 to 1 v power minus 1 to 1 minus v whole power 1 means it is in the structure of x power m minus 1 1 minus x whole power n minus 1 dx. Okay, that is m minus 1 equal to minus 1 by 2 and n minus 1 equal to 1. So m equal to 1 minus 1 by 2 is 1 by 2, n equal to 2. So we are having integral 0 to 1 we are having 0 to 1 we are having beta of beta of 1 by 2 comma 2 1 by 2 comma 2 into beta of 1 by 2 comma 3 by 2 1 by 2 comma 3 by 2 1 by 2 comma 3 by 2, and these two are constants, and here we will have dx. Okay, finally it will be here, but I am writing dx here. Okay, now what is b? B is 1 minus x. B is 1 minus x, that is a b c the whole square, abc whole square divided by 8 into integral 0 to 1 x power minus 1 by 2 into value of b is 1 minus x. Okay, 1 minus x whole power 3 by 2 dx. It is capital X dx. Okay, it is dx. Now we are having a b c, just a minute, and again we are having the constants, beta of 1 divided by 2 comma 2 beta of 1 divided by 2 comma 3 by 2. Okay, now for this we will have a b c the whole square by 8 of x power m minus 1 minus x whole power minus 1. So m minus 1 equal to minus 1 divided by 2, and n minus 1 equal to 3 by 2. Okay, n minus 1 equal to 3 by 2. Now m equal to m equal to 1 minus 1 by 2 is 1 by 2, n equal to 5 by 2, 3 by 2 plus 1 is 5 by 2. Okay, so ABC by 8, it is beta of 1 by 2 comma 1 by 2 comma 5 by 2, 1 by 2 comma 5 divided by 2. Okay, into beta of 1 by 2 comma 2 and beta of 1 by 2 comma 3 divided by 2, 3 divided by 2. Okay, now I am having a b c the whole square the whole square divided by 8 into gamma of 1 by 2 gamma of 1 by 2 gamma of 5 by 2. This is because of the formula gamma of 5 by 2 divided by gamma of 1 by 2 plus 5 by 2, that is 6 by 2. Okay, I am writing it separately first here. 1 by 2 plus 5 by 2. Okay, plus 5 by 2 into gamma of 1 by 2 into gamma of 2 divided by gamma of 1 by 2 plus 2. 1 by 2 plus 2, and here gamma of 1 by 2 gamma of 3 by 2 divided by gamma of 1 by 2 plus 3 by 2. 1 by 2 plus 3 by 2. 3 by 2. Okay, now we are having A, B, C, the whole square of 8 into 1 by 2 into 5 by 2. Okay, so first I should write everything. Gamma 1 by 2 gamma 5 by 2 gamma 1 by 2 plus 5 by 2 6 by 2 is gamma 3. Okay, gamma 3 into here gamma 1 by 2 gamma 2 divided by 1 by 2 plus 2 is gamma 5 by 2 gamma 5 by 2. Okay, then it is gamma 1 by 2 gamma 1 by 2. This gamma 3 by 2 can be written as n gamma n. If it is gamma n plus 1, then n gamma n will be 3 by 2 minus 1 is 1 by 2 gamma 1 by 2. 1 by 2 gamma 1 divided by 2 divided by 1 plus 3 is 4, that is gamma 4 by 2 is gamma 2. Gamma 2. Okay. Now we are having gamma 5 by 2 in both numerator and denominator will get cancelled. Gamma 2 in both numerator and denominator will get cancelled, and we are having some gamma 3 here, and 1 by 2 gamma 1 by 2 is here, and gamma 1 by 2 gamma 1 by 2 4 gamma 1 by 2 is here. Okay, so we are having A, B, C, the whole square divided by 8 into gamma 1 by 2 is root pi, gamma 1 by 2 is root pi, gamma 1 by 2 is root pi, gamma 1 by 2 is root pi. There are 4 root pi's, which means root pi power 4. Root pi power 4 root pi power 4 divided by gamma 3 is 2 factorial. Here is also 1 by 2, that is 1 divided by 2. Okay, 1 divided by 2. So we are having a b c the whole square, or a square. Okay, I shall write it as abc whole square into root pi power 4 is pi square, it is pi square, whole divided by 2 factorial is 2, 2 is also 2, 2 into 2 is 4, 8 4s are 32, 8 4s are 32. So we get pi a b c the whole square divided by 32. Okay, this problem is very important problem under beta and gamma function, and this is the most toughest problem that I have ever solved in beta and gamma, because it took 1 hour 6 minutes and 30 seconds for writing in the laptop screen using the laptop mouse pad. Okay, so it hardly ruins my time, and I feel happy. Even though it ruins my time, it is for the benefit of others watching this video. It is for the benefit of students who are watching this video. So being a teacher, being a professor, I feel happy in spending my time for the benefit of some students and some other persons who are watching this video to gain some knowledge under beta and gamma function. Okay, so thank you all for watching this video. I hope this video will be useful for you, and for this question is very important. Okay, so thank you all for watching this video. Thank you all once again.